Hello everyone. Today we are discuss about beam forming in multiple input and multiple output system. Beam forming is a type of radio frequency. It's RF management in which a wireless signal is directed toward a specific receiving device. Beam forming is applied to numerous technologies including wireless communication, acoustics, radar and sonar. The RF management technique direct radio and sound waves for signal transmission or reception. Rather than sending a signal from a broadcast antenna to be spread in all directions, how a signal would traditionally be sent. Beam forming uses multiple antennas to send out and direct the same signal toward a single receiving device, such as a laptop, smartphone, or tablet. The connection results in a faster, more reliable wireless data transfer. How does beam forming work? Beam forming works differently depending on its type or implementation. By having multiple antennas in close proximity send out multiple signals at different times, a beamforming tower or router can adjust the signal it sent. This adjustment determines the best path for the signal to take to reach the client device. In a sense, beamforming saves the RF beam as it traverse a physical space. Analog beamforming uses a phase shifter to send the same signal from multiple antennas. The signal is set to different phases, which creates an antenna pattern that points a specific direction. The signal phases of antenna signals are adjusted in an RF domain, which improves coverage. Digital beamforming has different signals for each antenna in a digital baseband. Digital receivers are placed at the radiating elements of each antenna. Different phases are applied to a different frequency band, enabling a digital beamforming to be more flexible. A digital beamforming processor can then steer numerous independent beams in any direction. This method is useful for spatial multiplexing. Benefits of beamforming: more power is directed in the beam specified direction. Higher signal quality reaches the receiving device, which increases the coverage capacity of the cell tower or base station. There are faster information transfer and fewer error. Signal interference between devices is avoided since signals are only broadcast where needed. Analog beamforming is relatively simple to implement and has a lower power requirement. Current limitation of beamforming: require more computing resources and power for beamforming calculations. Digital and massive MIMO beamforming systems may be more complex, especially considering more antennas and other hardware used. Its cost tends to be higher than traditional systems.